So for the second question, I have to make a table, and at the same time I have to solve these fractions by using the selfish method. So I'm going to work on these fractions. So we're pretty much done with the table here, and that is for question A. For question B, I was asked if I noticed some patterns that are involved when I was solving these fractions. I found this pattern with the help of my friend. So the pattern is 1 over n added by 1 over 2 in brackets, then added by 1 over n multiplied by n. This is the pattern that I found with the help of my friend. So I'm going to try it out with 2 over 3 to see if it works. So 2 over 3, I'm going to erase. So I'm going to put 1 here, and I'm going to put 3 plus 1 over 2 or divided by 2 in brackets. So I'm going to work this out first. So 1 that means that I have a half. Well, this half here is the largest unit fraction, and the other pattern is 1. I'm still going to try with 2 over 3. So 1 times the 3 is the denominator, and I'm going to multiply 3 by 2, which is the denominator of the largest unit fraction. So 1 over 6. 1 over 6 is the fraction here, while the other one, which is the previous fraction, is the largest unit fraction. So I discovered that one. So I'm going to try out with 2 over 5 so you guys can understand. So I'm going to start here. I'm going to write the pattern here. So n added by 1 over 2. So in brackets, I'm going to work this one first. So it's going to be 1 over 6 divided by 2 in brackets. So it's going to be 1 over 3. The other pattern is 1 over n multiplied by n. So it's going to be 1, the denominator of 2 over 5, which is 5, multiplied by the denominator of the largest unit fraction that I use here, which is 3. And I got 15. 1 over 15. So this pattern here is for discovering the largest unit fraction, while this pattern here is to find the fraction here. So I test with these two fractions, and the pattern worked. So I already explained from the last video how I'm going to answer question 3. Question 3 is about using appropriate mathematical notation Try to make rule or formula to find the Egyptian representation for any fraction that has form of 2 over k, where k is an odd number. And I use 2 over 3 and 2 over 5. 3 and 5 are numbers that are odd. I mean, like 3 and 5 are odd numbers. Odd numbers are numbers that can only be multiplied by itself or 1. So I'm going to move forward with question 4. Question 4 is I need to show you guys how I'm going to use my formula and see if like it works for every fraction in the table. So I'm going to start now. So since I've already proved that 2 over 3 and 2 over 5 can be solved with the formula that I use, I'm going to use my formula with these fractions, which is 2 over 7, 2 over 9, and 2 over 11. Plus, I'm going to since I've already proved that my formula works on 2 over 3 and 2 over 5, so I'm going to start with 2 over 7 and moving to the fractions below 2 over 7. So I'm going to start with 2 over 7 now. So 1 in brackets. So it's going to be 8 in brackets. So it's going to be 1 over 4, which is the largest unit fraction that I use here. Then I'm going to have 1 over 7, the denominator here, and the denominator, and I'm going to multiply 7 with the denominator of the largest unit fraction that I use, which is 4. So 1 over 28. You see here, this is the largest unit fraction, which is correct, and the result is here. It's correct. So I'm going to move a little bit fast with the other fractions. So yeah. For also, I'm going to work on the next question, which I have to use my formula on 2 over 13 and 2 over 15 to see if my formula works on when I'm solving these fractions. So yeah, I'm going. So this is another example. So I'm going to try with using the same formula to see like if the formula works out for this fraction. So it proves that my formula only works if the numerator is 2, not like 3 or 4 or 5 or any number but 2.